Welcome to The Explainer. Today, we're diving headfirst into a question that sounds wild, maybe even impossible. But trust me, physicists are actually thinking about it.
Seriously, could everything, you, me, the stars, galaxies, could all of it be tucked away inside a black hole that lives in some bigger, grander universe? Well, it's a head spinner, right? But it's not just late-night dorm room chat. Serious scientists mull this over. So how does an idea this out there even get off the ground? Well, it kind of starts with a look at the story we usually tell about our universe.
You know the standard picture, right? The Big Bang. About 13.8 billion years back, everything exploded out from this super hot, super dense state. But here's the catch. That starting point, it's supposedly a singularity, a point of infinite density. And infinity is usually where our physics kind of throws its hands up and says, I don't know. So what really happened right at the beginning? That question mark? That's where things get interesting.
So because that standard story has this big question mark, it leaves room for other ideas, like this black hole universe concept. And believe it or not, this idea gets its legs from some really surprising ways black holes and our whole universe seem to, well, rhyme, mathematically speaking.
Okay, quick refresher on black holes just so we're all on the same page. You get enough stuff squished down really tight, gravity goes nuts, and bam, you get a black hole. Its most famous feature? The event horizon. That's the point of no return. Cross that line and you're not coming back out, not even light can escape. And deep inside, theory tells us, lies another one of those pesky singularities, infinite density, physics breaks down again. See a pattern?
Right. Now let's look at our universe, kind of the same way. It also seems to have started from a singularity, the Big Bang itself. It's been expanding ever since, following Einstein's rules of general relativity. And here's a kicker. This expansion creates its own boundary, called the cosmological event horizon. Now, it's not a trap you fall into like a black hole's. It's more like a limit to our view. Stuff beyond it is moving away so fast, its light will never reach us. So we've got a start point singularity and a kind of horizon here too. Interesting.
So let's put them side by side. Both got singularities, both got horizons. Big difference, though, seems to be when. You fall into a black hole singularity, it's in your future. The Big Bang singularity, that's way back in our past. But okay, dig a little deeper into the math, and there's this fascinating similarity. Both are called space-like singularities. What that means, roughly, is inside a black hole, the singularity isn't just a spot you're heading towards, it's like an unavoidable future moment for everything inside. And similarly, the Big Bang wasn't just a point somewhere in space, it was like an unavoidable past moment that all of space came from. Weird, right?
Need a picture? Okay, try these analogies. Think of space-time around a black hole like water rushing towards a waterfall. Once you cross the edge, the event horizon, it doesn't matter how fast you swim, even at light speed, the current carries you over. Our universe expanding, that's more like raisin bread baking. The dough itself, space, swells up, carrying the raisins, galaxies, further apart from each other. The farther away the raisin, the faster it seems to move away, because there's more dough expanding between you and it. See the difference in dynamic?
But back to those singularities. Points of infinity? Physicists really don't like them. They're basically big flashing signs saying, your theory is broken here. Most think we need some kind of quantum gravity theory to figure out what really happens. And this need for new physics, it opens up some really cool alternatives that dodge infinity altogether.
So if infinity's out, what takes its place? Well, here's a wild theoretical idea, the white hole. You can kind of think of it as a black hole running in reverse. Instead of sucking everything in, it violently spews everything out. Nothing can get in, stuff can only leave. Now, does that sound familiar? A point in the past where everything bursts forth? Kind of echoes the Big Bang, doesn't it?
Okay, but how could you get from a black hole, which eats things, to something like a white hole, which spits things out? Well, this picture gives you the conceptual idea. Maybe, just maybe, when matter collapses inside a black hole, instead of hitting that infinite singularity, some powerful quantum weirdness kicks in. It stops the collapse and triggers a transformation. Maybe it turns into something like a white hole, blasting out matter and energy. Maybe even jump-starting a whole new baby universe inside.
And that brings us to the really key concept here, the Big Bounce.
Forget collapsing forever. The idea is the stuff falling into the black hole gets squeezed incredibly tight, but not infinitely. It hits some maximum density and then bounces back. What causes the bounce? Well, that's where the quantum gravity theories come in. Maybe it's some kind of quantum pressure, or maybe space-time itself has a kind of twistiness related to particle spin that resists being crushed completely. The details are fuzzy, but the main point is something stops the collapse, makes it rebound, and blasts energy outwards. And that outward blast? Maybe that's the Big Bang for a new universe born inside the black hole.
Check this out. People actually run simulations based on these bounce ideas. This plot here, it's showing the size, the scale factor, of a universe born inside a black hole according to one model. And look, it doesn't just crunch down to zero. It hits a minimum size and bounces back up. Some models even show it bouncing multiple times. And get this, near the bounce, conditions are so extreme they could actually create tons of new particles. That adds energy, meaning the universe could actually get bigger and bigger with each bounce cycle, maybe big enough to expand forever, just like ours seems to be doing. Pretty cool, huh? Here's how researcher Enrique Gastiñaga puts it. He says this bounce basically mimics the Big Bang. It gives us another way to think about our origins, one that maybe avoids that tricky singularity problem, using physics we kind of understand, just pushed to the extreme.
All right, theory is one thing. It's a neat story, avoids infinities, connects black holes and cosmology, but is it just a nice idea on paper? Or could there actually be clues, like real observable hints out there in our universe that point towards this? Let's talk about the hunt for evidence.
So what might we actually see? Well, here's a fascinating thought. Most real black holes probably aren't sitting still. They're likely spinning. If our universe popped out of a spinning black hole, maybe, just maybe, our whole universe has a slight overall spin too, like a giant, slow cosmic pirouette. It's a long shot, and while there have been some controversial claims like maybe galaxies observed by JWST prefer to spin in one direction, let's just say the evidence is really thin and heavily debated right now. Needs way more work.
What else are folks looking for? Well, besides that cosmic span, there are other potential hints. But again, we gotta stress, this is all highly speculative. Maybe there are leftover bits from before the bounce, like tiny primordial black holes that could have seeded the first galaxies. Maybe our universe isn't perfectly geometrically flat like we usually assume, but has a tiny bit of positive curvature. Some folks even wonder if those surprisingly big early galaxies JWST is seeing might fit better in a bounce scenario. And perhaps the most promising area is looking for specific, subtle patterns in the cosmic microwave background, that leftover heat from the Big Bang.
And speaking of the CMB, this is where the bounce model has had a potentially exciting success. Check out this plot. It shows what the model predicts for a key feature of the CMB, something technical called the Scalar Spectral Index, or NS. Now, the prediction depends on how efficiently the bounce cooks up new particles, basically just one adjustable knob in this model. And look, the predicted values, shown in red here, line up beautifully with the actual value measured super precisely by the Planck satellite, around 0.965. That's pretty neat. Proponents argue this explains a key observation with maybe fewer assumptions than the standard inflation models need. It's definitely intriguing.
Okay, so after all that, where do we stand? Is this idea of our universe being born inside a black hole a glimpse of a deeper reality, or is it just a fascinating but ultimately incorrect theoretical detour? What's the verdict?
Let's level here. Reality check time. This is way out on the speculative edge of physics. There's absolutely no scientific agreement on it and zero direct proof. Nada, zip. It's very much an active area of research where theorists are pushing boundaries, playing with ideas, trying to figure out quantum gravity, but it's not mainstream cosmology, not by a long shot.
I think physicist Sabine Hossenfelder captured the vibe perfectly with this quote. So, is the universe a black hole or a white hole? Probably not, but not absolutely not. That kind of nails it, right? Healthy skepticism, but acknowledging that we don't know everything and it hasn't been completely ruled out. But you might be wondering, okay, if it's so speculative, why even bother? Great question.
Here's the thing. Exploring ideas like this, even if they turn out wrong, is super valuable. It makes us challenge our basic assumptions, like that Big Bang singularity. It builds really interesting bridges between the universe at its largest scale, cosmology, and these incredibly dense objects, black holes. And crucially, it forces physicists to grapple with the big kahuna, quantum gravity, the theory we need to truly understand these extremes. Plus, hey, it offers a potential origin story that might sidestep some old problems. Pushing boundaries like this is how science moves forward, even down paths that end up being dead ends.
And so we end up back where we started, with a truly mind-bending thought. Just imagine for a second this is right, that our entire existence is playing out inside a black hole. What does that even mean? What's outside? What's going on in that parent universe? And could the black holes we see in our sky, could they contain universes too? Universes within universes. Wow. It's a dizzying, maybe even infinite rabbit hole to think about the true nature of reality. Thanks for diving down it with me on this explainer.